is CORDIScovery. Hello, welcome to this episode of CORDIScovery with me, Abigail Acton. Phones, watches, rings that quantify sleep. Technology comes in ever more diverse forms, and companies are focused on making the latest iterations covetable. How can the notion of wearables as must-have fashion be applied when it comes to assistive technology? The most sophisticated device is useless if it's uncomfortable, and however useful it might be, it's hard to feel enthusiastic about something that's ugly or cumbersome. Today's episode explores the way smart textiles are evolving in the world of assistive technology. We're looking at the interface between engineering, design, and application. Our three guests will show how technical constraints can be overcome to produce great devices people will want to use to remain independent in their own homes. Professor of Health Design and Human Factors at Coventry University, Louise Moody combines a background in psychology with a practical approach to design. Her focus is on developing health technology, enabling people to maintain their dignity and independence. Hello, Louise.
Hello, everybody.
Andrew Cobley is a Professor of Electrochemical Deposition and leads the Functional Materials and Chemistry group at Coventry University. Andrew's 20 years of electronic manufacturing now feed into his work on the electrochemical metallisation of non-conductive materials and the creation of next-generation e-textiles. Welcome, Andrew.
Thanks, Abigail. Yeah, hello, everybody.
Elif Ozden-Yenigan is a senior lecturer in textiles at the Royal College of Art. Her research concentrates on molecular materials design and innovative approaches to textile manufacturing. Elif's work has been applied to the fashion, automotive and aerospace industries. Hi, Elif.
Thank you, Abigail. Hello, everyone.
Louise, I'm going to turn to you first, if I may. You were the co-principal investigator on the Maturolife project, which set out to develop fashionable metallized textiles to be used in devices designed to help the elderly live independently. You approach the task from the user's perspective and feed that into design concepts. Can you tell us more about what that means in practice? How would you define good design?
So I've come at this project from a human factors perspective, which is really very much about understanding and making the best of people's capabilities by designing things that are fit for their use. Typically, in a human factors context, we're looking at increasing productivity, enhancing safety and comfort, and minimising error, and bringing in a range of different disciplines to enhance our design process. And in this particular project, we've applied it in a number of different ways, but we've been looking not only at a good design process and methods for enhancing what we produce, but also looking at well-designed products. And from our perspective, that's been about working with the end users, the people that we want to use these in the end, to ensure that we've met their needs.
Right. And I mean, there are assistive products, obviously, already to enable people to live independently. I'm thinking, for example, of a fall detector that my mother has, but it's not something she takes any pleasure in wearing. It's quite large. It's not at all attractive and so on. So when you were consulting with user groups, what were some of the things that you were hearing about what they were looking for themselves?
That's exactly the space that we've been looking at in this project. We know there's a raft of assistive technology out there available to people, but we know they don't necessarily want to use it. And they might well buy it and it might end up in a cupboard. And what we're particularly interested in is how we tackle some of those emotional issues around the purchase and use of assistive technology to ensure that people get the best benefit from it that they can. What we know is that often there might be a stigma associated with use that might be, for example, drawing attention to somebody's age or something they can't do. And therefore, it's not desirable for them to own and use that technology. So what we're interested in is designing with subtlety and how we might embed assistive functions that aren't necessarily obvious to everybody around them.
And what sort of prototypes was Maturolife developing when we're talking? Can we talk more specifically about what you were actually producing?
Yes, we've worked on three particular areas. We've been looking at footwear, we've been looking at clothing, and we've been looking at furniture. So products that people have around their houses, or on their person, that could embed some assistive functionality to help them out day to day. So we've looked at footwear to help improve balance. We've looked at clothing to help people stay warm. and to collect vital signs about their body. And we've also looked at furniture to help people develop healthy sleeping routines and help them to keep active.
Right. Okay. That sounds very interesting. So you're coming at it from various angles. So you're obviously sort of immersed in the user's needs and coming at it sort of empathically from trying to understand and identify what might be causing them to hold back from using something and so on. How do you see the domain of assistive technology developing more generally, though, beyond this particular project? Where do you think this is going to go ultimately? Where would you like it to go?
I think our key agenda really from the combination of design and materials is about developing things that fit more seamlessly in day-to-day life. We know, for example, we've got an aging population and there's a growing market for products in this space, but a resistance to necessarily buy and use them. I think we need to look at more in-home solutions that enable people to stay at home, living alone potentially, but independently within their own environments. And that's where we need to be looking at that consumer market and how we make products desirable for people.
Excellent. Well, I'm sure my mother, for one, would be delighted with all the work that you're doing. Does anyone have any questions for Louise? Any observations to make?
Louise, this was obviously a European project. We had representatives from 9 different countries. So did you notice any cultural differences in the co-creation workshops?
We did. We had a range of older adults particularly involved from the 9 different countries that were partnering on the project. And there were some obvious differences, for example, related to the weather, the British weather, and how that might very much affect what people wanted. And I think there's also cultural differences in terms of the amount of support that people have around them in their local areas, depending on the country. But we also saw lots of commonalities in terms of the types of concerns that older adults had as they age, the things that they feel vulnerable about, but also the sorts of things that their families were interested in supporting them with, but also the things families might want reassurance over. So one of the recurring themes was particularly around falls. And that's where some of the products that we've developed really sort of fit in the space around falls, firstly in terms of falls prevention, but also in terms of providing alerts and safety systems in the event of someone falling. So both our footwear solution and the furniture-based solution were about people being able to make contact and maintain connection with others.
Okay. Wonderful. I certainly would be delighted if someone was able to provide that for my parent, and I'm sure other people as well. Andrew, I'm going to come to you because very interestingly this time we're actually inviting 2 guests from the same project. So Andrew, you were also on the Maturolife. You were the principal investigator on the project and you worked alongside Louise. Unusually, we're looking at this project coming from 2 different angles, the design and the technical development and the interface between the 2. So you brought your expertise in electrochemical deposition to Maturolife. What were the key challenges presented by the goals of the project in terms of the actual chemistry side and the actual making of the textiles, and why were you attracted to solving them?
Okay, well, my background is in electronic manufacture, and in particular, I specialized in developing processes to selectively metallize non-conductive materials. So developing a process to selectively metallize a textile was very attractive to me. From the materials perspective in the project, what we wanted to do was to produce electronic textiles that were better integrated into the textile itself. So rather than, for example, adding wires into the textile, which can make the textile very stiff and heavy, our approach was to actually metallize the fibers within the textile to encapsulate them with a very thin layer of metal, and in that way introduce conductivity. So the idea was to produce a multifunctional material. So because we only produce this very thin layer of metal, the textile retained some of its properties, such as being flexible and light, but we've now also introduced conductivity and sensing abilities, for example. I think one of the important things, however, to remember was that, science is littered with the debris of many great ideas that never saw the light of day because no one wanted to use them. And it would have been very easy for us to have chosen a particular textile that we could easily print or we could easily plate. But we needed to talk to the design team and understand what they needed and what the end users needed in terms of a textile. And we both had to make compromises to achieve our objectives.
That's what really interests me is how you worked and how these two disciplines meshed together to produce these prototypes. What technological aspects or approaches did you explore before you finally arrived at the way that you solved the problem? In other words, I know that you used copper, but did you try to use other materials and other metals? How did you go about actually arriving at the end result?
Well, we used a process known as electroless copper plating. That's a very well-known process in electronic manufacturing, and in particular printed circuit board manufacture, to achieve electronic connectivity. Now, this process requires a catalyst, and wherever you want to get your copper deposited, you need to put your catalyst. So that is very useful if you want selective deposition. Now, traditionally, that catalyst is based on palladium. Palladium is very expensive. It's also a critical raw material. So the approach we wanted to do was to develop a non-precious metal catalyst, and we decided to work on developing a copper nanoparticle catalyst. But we also wanted to be able to print that catalyst so that we could print it onto the textile and selectively metallize the textile to create circuitry and sensors. And that was probably one of the biggest challenges, actually, because we had done work in the past on using copper as a catalyst, so we knew that would work. But then formulating it into an ink is not an insignificant challenge. Yeah. You have to get the viscosity right so that it will print. And also, once it's printed, you don't want it to spread because then that could cause short circuits. So, once we had printed our catalyst, we were able to plate it with electroless copper, around about 2.5 microns of copper. And the reason we chose copper was because it's got very good electronic properties, and it's cheap, relatively cheap, and it's earth abundant.
Okay, that's great. So we've just heard Louise talking about the various prototypes and the various objects that were being developed, and the shoe concept is quite an interesting one. Can you tell me more about how then what you developed was integrated within a shoe, and what was that setting out to achieve?
We did use the printable catalyst to print circuitry onto an insole of a shoe. And that was quite a challenge because, again, I mentioned that to produce this circuitry, you need a certain gap between the lines of the circuit. And so, as I said, we need to make sure that catalyst didn't spread. But yeah, that allowed us to get our conductivity and connectivity on the insole, and also we were able to print copper to where the pressure sensors would connect into the insole.
And what did that show for a user? What were you hoping to learn? What was it about gait or?
Exactly, yeah. So I think what is important to realize is that these were prototypes and not perhaps the finished product. That what we wanted to do was to show what would be possible with further development. So the idea with the insole and the shoe was that you would be able to get a pattern of your walking as you walked along. So using machine learning, the computer, if you want, or the brain, the electronic brain could understand what your normal gait, what your normal walking pattern was like. And then if it detected any variance from that could be a warning signal. Something's changed here. It could send a signal to either the user themselves and say, we think something's wrong, you need to sit down. Or it could send a signal to a carer or a family member and say, we think there's a problem here.
Okay, excellent. Yes. So a way of providing reassurance and an early alert, perhaps, to those who are concerned.
Yeah.
Yeah, super. Any questions at all for Andrew? Yes, Elif, what would you like to ask? or say?
I'd like to ask, how have you found the experience of working with textiles and textile processes? Because the processes are pretty fast and also open to hand interventions, which is, like quite different than the electronic film and circuitry production.
Yeah, well, we tried to use a similar process, really. I mean, we didn't go to the sort of full-scale production. So, we had a piece of textile which we printed onto, and then we plated, and then we, formed it into the sort of shape that we needed for the various prototypes. So, I mean, working with textiles, as I say, it was more difficult because, chemistry soaks into a textile, it can spread out. So we needed to try and avoid that. To some extent, we wanted it to go into the textile so that we'd get very robust and good electronic conductivity, but also we didn't want it to spread too much so that we got short circuits. So yeah, it's we certainly learned a lot throughout the process of using a very different type of material.
Okay, thanks, Andy. I'm going to turn to Elif now. Elif, you took on both Andy and Louise's roles in your Horizon 2020 project, GF Smart. You were developing ways to seamlessly integrate communications technology into textiles as well, but while at the same time maintaining the wearer's comfort. So for you, the electronic components had to be lightweight and compact and flexible and unobtrusive. So it sounds like a tall order. What attracted you to this area of research? Why were you enticed by these challenges?
We live in a connected world, and as humans, we are part of this connected network, voluntarily or involuntarily. So in the smart textiles, I pretty much focus on the antennas. So antennas are the essential part of the communication. So they can receive signal or send signals, or in some constructions, they can do both. So in the field that I'm much more interested in, how you tune the antenna also defines the communication channel for us, the bandwidth and the nature of data. So this was quite fascinating because this data could be your location information or health data such as heartbeat or body temperature, or any other information that is secure enough to transfer wirelessly, basically. And we live with textiles, which is a pervasive element to human perception, isn't it? That's why, as a material scientist, I am more into creating textile version of these electronic components. And in my research as well, I believe we are heading to a more soft version of devices. You may have heard the term of flexible electronics. From the materials and the textile point of view, the antennas called wearable antennas, usually designed by communication engineers, but they do not fully meet the haptic needs of users. Thus, I have been always in search of these alternative material systems that align well with the user acceptance.
So I think, just to clarify, so what you're saying is that in the past, the antennas have been designed perhaps with a certain goal and in a certain manner, and you were selecting to design them with a different application, in other words, embedded in fabric, which then meant that they had to be much more tactile. I know that you've told me before that one of your main concerns was making fabrics almost the same, in other words, for the antennas to be almost indistinguishable. What materials were you looking at for your antennas? So we know that Andrew, for example, was using copper in order to construct circuits. When you were coming to integrate your antenna into material, in order to keep that material feeling normal, what were you using?
We use carbon, an allotrope of abundant carbon, which is 2D honeycomb structure called graphene. And graphene promises many remarkable properties, such as a large surface area, high electrical conductivity, high thermal conductivity, high optical activity, which is also quite important for us, and high mechanical strength. However, it's a bit tricky to transfer this theoretical superiority into the practical life. This is where the material scientists actually use textiles. And in practice, graphene's conductivity is not as high as the common metals such as silver, copper, or gold in e-textiles. But once you have the ability to control the textiles, then you can control the electromagnetic radiation and the response of these graphene surfaces onto the textiles.
Okay, and why the imperative to do this at all, Elif? What was the ultimate goal with these materials that you were producing? How were you hoping they were going to be used?
I mean, first of all, there are lots of issues around bringing metals into the textile products that we just started to realize, actually. So electronic textiles, in short, e-textiles, are about to face this tremendous environmental and resource challenges due to the complexity of sorting and the risk to supplies, and also metal contamination in the textile recycling streams. And the textiles and also the electronic industry is a bit behind of putting regulations into these mixed material systems. And we are trying to embrace not a human-centered approach, but also a planet-centric approach, and explore other natural materials in the antenna design, in the wearable antenna designs.
To do what? What would be the purpose of these materials?
Is to create some communicating pieces which is embedded in the textile itself, in the garment itself.
Okay, for who?
I mean, it depends. Initially, when we proposed the project, it's for the people who suffer from Alzheimer's, and we just proposed this system as a unobstructive way of tracking people. So who have, high touch sensitivity or, being touched. But ultimately, it's not limited with tracking, the location tracking. You may also tune your system a bit to, monitor your health data.
Right. Excellent. Well, thank you very much. Fantastic. Does anyone have any observations or questions to put to Elif at all?
Elif, how did you integrate the graphene into the textile?
So there is this hierarchy in textiles, starting from the yarn. We use different approach. So there are some ways to, use graphene as a coating. That's one thing. In antenna application, we prefer to use them as a laminated structure, which is, attached to the cellulosic structure using a bio-driven binder.
What was the binder?
Yeah, it's a bio-epoxy. It's not like an epoxy one, but it's like a gum.
Okay.
It just attached to the cellulosic substrates.
Okay. Any other comments or observations?
Well, another comment I would make, I think Elif made a really good point about e-textiles and how that could add to the issue of electronic waste. And actually, it's an interesting point, because one of the things we want to do is to better integrate electronics into textiles to make them more sort of invisible, if you like. So you don't realize so much that they're there. But on the other hand, that also means it's more difficult to separate. So that means that you're going to end up with wearable technology. And both the electronic industry and the textile industry have a terrible carbon footprint and a terrible environmental impact at the moment. And actually that could make it worse. So it's an interesting point, and it's an interesting area that we need to think about, those of us working in that area.
Yeah, indeed. So try and find ways of making them spring apart, or alternatively, I suppose, use conductors that are somehow able to be recycled in the same way as fabric. I have a question that I'd like to ask all of you, because this is the central thing that fascinates me about this work that you've all been doing, really, is the way that you all come together with different disciplines. Now, Elif sort of did a bit of both. She was coming from the design and also from the technology angle. But generally speaking, to all of you, what have you learned from working with people whose areas of expertise differs from your own? Louise, can I come to you first for that one?
Yes, and we certainly had a range of different disciplines in our project, and I don't think it's just differences in terms of disciplines either. We've got different languages, different cultures, different discipline backgrounds and languages, which can make it not only exciting but also challenging at times in terms of coming up with a shared vision for the direction we're going in. And I think that's also probably one of the things that we've enjoyed most or achieved most in terms of the project is moving together in terms of different disciplines and working out how to negotiate some of those challenges. I think one of the ways we tried to tackle that in Maturolife was using design management approaches and the ways of communicating and workshopping that we would use in a design discipline in terms of sharing ideas and developing pathways. And that was embedded in the way we ran many of the project meetings over the period of time. And of course, we also had the challenge of the pandemic and the fact that during the project, we shifted to working remotely. And that caused a number of challenges for the individual disciplines and for us coming together. In some ways, we all became much more familiar with working online in this way, which we would do routinely, I guess, as part of European projects. But we also, as individual disciplines, had to adapt our working methods. And that was very much something we had to work through the latter stages of our particular project.
Yeah, unexpected challenges and hurdles halfway through or whatever. Yeah, lots of people experiencing that. Andrew, how did you feel about working with designers, but coming from a background in chemistry and so on?
There were a lot of aspects of design that I found really interesting, actually. I found the whole idea of co-creation really interesting. And actually, some of the approaches that I learned from design are in fact transferable to scientific research. I mean, I lead an applied research group, and what I mean by that is that we try and make our research industrially relevant. So, for example, one of my PhD students a few years ago, she did a project on producing a magnetic catalyst for the same process that I've talked about already. It was a very successful project. But the idea behind that actually was that instead of using printing to put it down selectively, we could use a magnetic field. So it was very successful, and we even got a patent out of it. And we took that to the commercial world for that reason. Now, we got a lot of interest, but they weren't interested because it was magnetic. They were interested because it wasn't a precious metal catalyst. And so that kind of told us that, if we'd done perhaps some sort of co-creation process at the start with relevant end users and industry, perhaps we'd have saved ourselves a lot of time and effort in making the catalyst magnetic, and we could have focused on the non-precious metal side of things. So, there are lessons to be learned there, I think.
Yes, absolutely. Great. Elif, any experiences that you've had working with people who, for example, don't normally come into contact with material or who don't normally come into contact with circuitry?
I mean, I know communication is challenging most of the time, but as an engineer, I even struggle, talk to physicists, you know what I mean? So I know the challenge, but I found it quite fascinating. It just because, if you just, have the opportunity to discuss a textile processes with a knit designer or a weaver, they just basically show you how you can just basically hack the machine, which is, quite unlikely for an engineer because the whole processes are quite automated. But if you have a very specific function or very specific design, then these are the people that you need to go first because they know the tools much better than the engineers sometimes, and they can be much more open-minded because their priorities are different. They do not talk about the efficiency or the automations or the speeds, but they can just basically show you how you can just basically create something unique based on the tools, based on the materials you have, and they can work with very small quantities, which is quite important for, material scientists like me, because we are not always, able to produce kilograms of, nanomaterials, which is quite important.
Yeah, that's great. So basically it's, I suppose it's a completely different approach that then makes you rethink your own. Well, thank you very, very much, all of you. Thanks for your time. That was really interesting, and I'm grateful for you having appeared.
Thank you so much.
Thank you. Bye.
Thank you, Abigail, and goodbye.
Very welcome. Goodbye, everyone.
Are you interested in what other EU-funded projects are doing in the realm of smart textiles? The CORDIS website will give you an insight into the results of projects funded by the Horizon 2020 programme that are working in this area. The website has articles and interviews that explore the results of research being conducted in a very broad range of domains and subjects. From quarks to quails, there's something there for you. Maybe you're involved in a project or would like to apply for funding. Take a look at what others are doing in your domain. So, come and check out the research that's revealing what makes our world tick. We're always happy to hear from you. Drop us a line, editorial@cordis.europa.eu. Until next time.